So let's walk through this example on how to predict whether a salt solution will be acidic, basic, or neutral. Okay, and again, this is going to require you to understand a number of things. So I want to point out the steps of analyzing salt type problem. First is you want to determine your cation and anion in the salt. And then once you separate them out, you want to determine whether your cation is going to be neutral, acidic, or amphiprotic. Right? Three different possibilities. You want to do the same analysis with your anion, except the anion is going to be neutral, basic, or amphiprotic. And then once you determine each one of them, you combine the properties of the cations and anions to come up with the properties of the salt. And it simply will look something like this. If the cation is acidic and the anion is neutral, you're going to get acidic salt. If the cation is neutral and the anion is basic, you're going to get a basic salt. If the cation is acidic, the anion is basic, you're going to have to compare the Ka of the cation, the Kb of the anion, see which one is larger, and that one is the one that's going to determine the property of the salt. So let's walk through these examples. There's 5 different salts here. We're going to first look at ammonium iodide, okay, NH4I. So step 1, break them apart into cations and anions, because that's what they do in water. These two would break apart into NH4 plus and I minus. Now this requires you to remember how to do this from Chem 11, okay, so I'm not reviewing that here, but just to know how to break ions apart, standard charges, and all that. What we need to notice here is that ammonium, you have to characterize that. Is that acidic, neutral, or amphiprotic? Well, ammonium is the conjugate acid of a weak base, the weak base being ammonia in this case. So if it's a conjugate acid of a weak base, then that's an acidic cation. I minus is the conjugate base of a strong acid, the strong acid in this case being HI. And if the conjugate base of strong acid, it's neutral. And again, how do I get this information? You go back to this part of the notes where we talk about type of cations, type of anion. Okay, so I have a neutral anion, I have an acidic cation, salt is going to be acidic. Okay, all right, the second salt is sodium nitrite. Sodium nitrite associates into sodium and nitrite ion. Sodium is a group 1 cation, so it's going to be neutral. Nitrite is the conjugate base of a weak acid, so therefore it's going to be basic, right? The weak acid here being HNO2, so therefore this thing is going to be basic. You have a neutral plus a basic, you're going to get a basic salt. And the third one is FeCl3. FeCl3 breaks apart into Fe3 plus and 3Cl minus. The key here is not necessarily to look at the stoichiometry, but more the type of cations you have. Fe3 plus, well, that's a small, highly charged transition metal cations, and we know that that's going to be acting as Lewis acid, so it's going to be acidic. Cl minus is the conjugate base of a strong acid being HCl in this case, so it's a neutral species. So you have acidic and neutral, salt is going to be acidic. We're going to go to the other 2 problems in another part of the notes, but I want to point out first before we go further that you can potentially be asked to calculate the actual pH. So if I say, for example, what is the pH of 0.1 molar of ammonium iodide, you can calculate it because once you know that it's breaking apart into NH4 plus and I minus, it's the NH4 plus that's going to determine pH. So another way to ask that question is, what is the pH of 0.1 molar NH4 plus? And you know how to calculate that because that's just asking you how to calculate the pH of a weak acid, which we learned how to do a couple of lectures ago. So even though in this problem we're focusing only on determining whether it's going to be acidic, basic, or neutral, for some of these problems you can very easily and likely to be asked also to calculate the pH value of the salt. So now we're going to go to the other 2 problems. This is NH4F and then later on NaHCO3. So NH4F, this is our salt. It breaks apart into ammonium and fluoride. The reason why this is more complicated is because ammonium is the conjugate acid of a weak base, the weak base being ammonia, right? So that means that ammonium is acidic. F minus happens to be conjugate base of weak acid being HF, so this then be basic. So you have acidic and basic. Remember that when we have that situation, we're going to have to now compare who's stronger, who's going to drive the reaction. Is it the cation or is it the anion? So I'm going to have to find Ka and Kb value. The Ka of ammonium is actually given in your Ka table. It's just 5.56 times 10 to the minus 10. So you can get it directly from the Ka table. But let's say you don't have a Ka table, but you have a Kb value of ammonia. You can then calculate using Kw over Kb. Okay. Now we then have to compare that to the Kb of fluoride. The Kb of fluoride is not given to us, but the Ka of HF is given, so we can use Kw over Ka to calculate the Kb of F minus, and that ends up being 1.52 times 10 to the minus 11. So the 2 numbers we're comparing are Ka of ammonium, Kb of fluoride. Well, it looks like the K is larger than the Kb. So in this case, the salt is going to be acidic. Now let's take a look at our last problem salt section, which is sodium bicarbonate. Sodium bicarbonate is a salt that would break apart into sodium and bicarbonate. Sodium is neutral, it's group 1. Bicarbonate is a little harder. It turns out to be amphiprotic, right? It could act as an acid or a base. So similar to the idea that when you have two different things, you have to analyze what it's going to do. Here you have to compare the Ka and the Kb of bicarbonate and see which role it's going to take on. This is bicarbonate acting as an acid where it's going to donate proton to water, forming hydronium and carbonate ion. So the Ka there is going to be 4.7 times 10 to the minus 11. That I just get from the Ka table. Here's bicarbonate acting as a base where it actually accepts a proton from water, forming carbonic acid and hydroxide. The Kb here, I don't have directly, but I can calculate. And that's what I did in the next step. I find the Ka of carbonic acid, which is the conjugate acid, use Kw, and then I find the Kb of bicarbonate is 2.27 times 10 to the minus 8. So again, what two numbers am I comparing? It's this one versus that one. And I find that the Kb in this case is larger than the Ka. So the Kb is going to dominate. So the amphiprotic anion is basic. So the salt is also basic because the other ion is neutral. Now the most complicated of this problem would be if you have an amphiprotic here and then you have, let's say, an acidic one here there, right? Then you really have to go through like multiple steps to get to the bottom of whether the salt is acidic or basic.